Hi, it's time to go through your mock paper in preparation for your WA3. Okay, I will skip certain questions that are not really going to be tested. So question 1, this part not tested because this one is your bonding. We only testing you on metallic bonding. So for metallic bonding, the main thing we care about would be your metallic bonding itself, the melting boiling point question, the electrical conductivity question, and your alloy question. Or what is alloy? Why is steel, which is alloy, hard, and why is iron, the pure metal, soft? Pretty much those are the standard stuff. Okay, so part C, oxides. Yes, we do learn oxides if you recall. So there are 4 types of oxides, right? Your basic, your acidic, which are the main ones. Basic is what? Metal oxide, ma? So you recall what's the base? Base is any metal oxide, any metal hydroxide. So acidic is the opposite, non-metal oxide. You have amphoteric. Amphoteric is exception, remember? Amphoteric is your lazy. But there's no why lah, don't ask why. So aluminium, zinc, lead. And you have your neutral. Neutral is no cold water, remember? No cold water. So in this case, silicon dioxide. Silicon dioxide is basically a acidic oxide. And how do I know that? Because this is a non-metal. Amphoteric. You're supposed to give an example of amphoteric oxide. So you notice they're writing here in terms of name. So you give them lah. So you can write zinc oxide. You can write lazy, right? Aluminium oxide. Your lead-2 oxide. Or possible. Potassium oxide. Potassium oxide is a basic oxide. So universal indicator. So if you recall, basic oxide dissolve in water to form alkali. Refer to that table that I've sent to you before, that summary. To form alkali, and not all of them, very limited of them. It's actually your group 1, your baka. So your K2O will actually dissolve in water. K is group 1, right? So you get KOH. This thing is your alkali. So think about it. Alkali in universal indicator, this is a strong alkali. You will get purple. Right? Because why? Remember, your pH 7, this is green. Then your 0 to 2, this is strong acid, this is red. 3 to 6, orange. Then your 8 to 12, blue. The very alkali will be purple. This is for universal indicator, which you need to know. Metal orange and all these, I wouldn't really be so worried. I really need to know your universal indicator. Oh, mole. Sure, let's do mole. So if you recall, my hashtag hack for mole is number 1, equation. Number 2, change to mole. And lastly, mole ratio. So in this case, I am not gonna write a equation because nothing is reacting. It's just telling you that this sample has this. It's not reacting anything. So first step, I'm not gonna care. Second step, change to mole. Once I see empirical formula, it means that I need to have a table. Okay, not this table lah. This table. So we are given carbon. So carbon, hydrogen, and oxygen. So apparently you are given mass. Sure, 1.22, 0.21, 1.59. This is your mass / gram. So this one, It is normally percentage by mass slash percentage. So either way works lah. Both way is fine. Just know that because that, yeah. So next one, change to mole. So this is your step 2, change to mole. Step 3, mole ratio. 1.22 divided by 12. 1.22 divided by 12. 0.1017. I'm leaving it for SF. The final answer of each part, like part A lah, part B lah, 3SF. My in between answer is always 4SF. 1.59 divided by 16, I get 0.09938. Then last step, ratio. Ratio means you divide by the smallest mole. So the smallest mole I have is 0.1017 divided by 0.09938. 0.1017 divided by this, I get 1.02. 0.21 divided by 0.09938, you get 2.11. Actually, pretty much is a 1:2:1 So don't stop there, because you need to tell me the empirical formula. This table don't tell you the empirical formula. You need to tell me. So the empirical formula is CH2O. Yay, cool. So empirical formula is one of those standard things they ask. Okay, next. This one. So if you recall, the MR of the empirical formula times n is basically a constant, or in layman terms, a multiplier lah. Times 2, times 3, I don't know, equal to the MR of the molecular formula, or basically the real thing lah, the real thing. So this is 12 plus 2, 1 plus 16 times n equal to 360. 12 plus 16 plus 2. 30, n equal 360. N equal 12. Right, 360 divided by 30. So therefore, the molecular formula is 12 times of it. So C12, H24, O12. C12, H24, O12. 12 times 12 plus 24 plus 12 times 16. Ta-da! Finish. Okay, next one. So if you recall, I said this before. So of course you need your hashtag hack. Hashtag hack. Yeah, hashtag hack applies. Hashtag hack. So if you recall, I said before, when all are gases, or all but one are gases. Let me give you an example. So CH4G plus, all plus this one gases. Let me think. So gases means this gases, G, they're all G. All but one would look something like maybe C2H6G plus O2G. If you CO2G plus H2O L. Then when you balance it, you realize that 2, 3. So this is a 2, 4 H2O. 6 H2O. 4. So 6 is 3, 3, 4, 7. So you can see in this case, G, but this one not G. So in these two situations, you can shortcut What is this shortcut? You can let mole ratio equal volume ratio. So what does it actually mean practically in your calculation? It means I don't need to change to mole for my gases. I can compare my gases, the volume. So I'll start off by writing down lah. Let mole ratio equal volume ratio. Means I'm gonna compare volume only. Yay! But what if for you, right, you decided you don't want to know this? It's fine. You can just change the mole and calculate normally. You should still get the answer. But this is a shortcut. Only when all are gases. Or everything except one is gas. So let's take a look. I can find the so-called volume or the mole of both my reactant. Both. Remember? What does this mean? This means that something is fishy. Something is sus. Means you need to check if there's limiting. How do you show? Okay, let's try lah. So let's look at the ratio. So my focus now is, so I can see that 1 CH4 is to 2 O2, right? So I'm gonna write. Also, if I have 200 dm cube of methane, I need 400 dm cube of O2. You need it for what? You need it for complete reaction. To react finish. How I know it's 400? The ratio is 1:2 ma. So 1:2, 10:20, 200 is to 400 lor. But my actual volume is what? My actual volume of O2 is, I have 300. I need 400. I only got 300. So this is less than needed. What I have is less than needed. Which means O2 is my limiting. Because not enough what? Limiting reactant, limiting reagent, same thing. Yeah. Okay, we don't stop there, right? We continue. Because what they want? They want carbon dioxide. So I can see 2O2 is to 1 CO2. So, 2O2 is to 1 CO2. Okay, let me rewrite it. Mole of O2 is to mole of CO2. 2:1, but I don't have 2. I have 300 cm cube. Mole or volume. You can only do this mole or volume thing when it's all gases, or all but one. So 300 is to 150 dm cube. Therefore, volume of CO2 is 150 dm cube. Yay! Okay, next. I'm supposed to calculate the total volume of, okay, this question the next part is scary. Why? So let's take a look. I have CH4. So CH4 is methane. Methane at room temperature still gas. Oxygen, oxygen is a gas lah. Room temperature also gas Carbon dioxide also gas. But H2O is not a gas Because room temperature. Your room so hot No, right? Okay. So out of all these, I know that this is limiting. Limiting means no more left. Because finish, not enough what? Sure finish one. That means I will have this, I will have this. So let's figure out So just now we already figured out I need another color This we earlier on figured out already. We know this is 150 dm cube. Then mole ratio So mole, with volume. Volume of O2 is to volume of CH4. 2:1. So 300 dm cube will react with 150 dm cube. So volume of CH4 left, you start off with 200, right? So 200 minus 150 equal 50. So this is 50. So total volume equal 50 plus 150 equal to 100 dm cube. Oh, no. Seems like the part B is a little bit more challenging than usual. Okay, next. We are supposed to compare the strengths of both acids. Okay, let's compare the strength of both acids. So, if you need to recall what is a strong acid. Strong acid dissociate or ionize fully in water. Must be water, not alcohol, not lime juice or Coke. In water to give you what? To give or to produce a high concentration of H plus. Yep, so that is what happens. So if strong acid is 100%, weak acid not 100% lah. Weak acid is the same thing. Weak acid dissociate or ionize partially in water to give a low concentration. It's a comparative term lah. So low concentration of H plus. So that's how it works. Then okay, so that's just a basic definition. So let's compare the definition with the data. Oh, they say it's completely ionized. That means HCl is strong. Cool. Then this hydrofluoric acid thingy you don't learn, right? But what did they say? They say only 10%. Isn't 10 lesser than 100? If 10 is lesser than 100, it means it's partially ionized. Oh, so hydrofluoric acid is weak acid. Cool. Yeah, just process the data normally. No need to panic. So just tell them, HCl is a strong acid. Has strong acid ionize fully okay, in this case space is very tight. Strong acid ionize fully in water to give H plus ion. Then I'll tell them HF is a weak acid. So be careful. I don't like to use the word stronger or weaker. Because once you bring in stronger, weaker, it can be a bit more vague. So I'd rather use the word strong and weak. If not, it's very confusing. So it's a weak acid. How do you know? Because weak acid ionize partially. You can put a 10% here because this 10% is given a question. H plus ion. Yay. So compare the pH. Okay, I don't know any number of pH here, but it's okay. So let's think about it. Dissociate. You think dissociate more means more H plus, right? I thought H plus means acid. More acid shouldn't means more acidic. More acidic means what? pH nearer to 1 or nearer to 7. The pH should drop. Then let's compare. So I'll say that HCl has a lower pH than HF. Why is that so? Because the concentration of H plus in HCl is higher. Because dissociate. Finish. The other one never finish. Yep. Okay, next. Okay, calculation, sure, bring it on. Let's try. So first step, equation. We have the equation, yay. Second step, let's change to mole. Okay, so be careful, be very careful. You see the word here, U? Remember I said that for U, when you see the word U and purity, you need to have a step 0 of my hashtag hack. Huh? How? Don't panic. So remember, YP, U, product. So U refer to product. Means the question given mass of product do not touch. Or basically do not convert lah. So what is this number here that I cannot touch? Product. Hey, NAF so that means this 0.9 gram, leave it. Okay, cool. That's step 0 lah. Then step 1, equation we have. Step 2, mole. Then change to mole. So the only number left that I can deal with is this number. Sure. So mole of HF is 25 over 1,000, sorry, times 1 equal to 0.0250 mole. Oh, cool. You have found the mole. Next, ratio. Okay, let's ratio then. So the mole of HF that I can see in the inside here, what I have is this. I have this. I want to find sodium fluoride. Oh, 1:1. Cool. So mole of NaF 1:1, but I don't have 1 mole. I have 0.25 mole, which means this one also gonna get 0.25 mole. Cool. So then after I'll find the mass of NaF. 0.025 times 23 plus 19, I think. Let's check. 23 and 19. Yeah, I'm right. 23, 19. I will get calculator. 23 plus 19 times 0.025. 1.05 grams. So if you recall, percentage U, percentage purity is always the smaller mass divided by the bigger mass, right? So the percentage U is 0.900 over 1.05 times 100. And that will give you a percentage of 0.9 divided by 1.05. You get an answer of 85.7%. 3SF. Yay. So it's as simple as that. Okay, next. Why must the litmus paper be moist? This is a very, very common thing that they like to ask. Okay, so let's take a look. So, why must it be damp? Sure, let's try. So, it's basically a definition, isn't it? So, we know that in the water, hydrogen fluoride dissociate or ionize in water to form what? To form H plus ions, or technically H plus AQ ions. And why so important? Which is responsible for the acidic properties or the acid properties. So without the water, so you see, if there is no water means no H plus AQ, means not going to behave like an acid. It's just like an acid. Means your litmus paper nothing will happen. So that's how it goes. Yep. Okay, next. Oh, time for some reactions. Yay. So, okay, a quick recap. Remember a few reactions here. You have your acid plus base. Acid plus base give me salt plus water. Next one, acid plus carbonate. Salt plus CO2. Salt plus CO2 plus water. Third one, acid plus metal. Salt plus H2. Last one, alkali plus ammonium. Salt, give you salt plus ammonia plus water. So then let's take a look. What's happening here? I don't know what's happening, but let's take a look, shall we? So if you look carefully, you add universal indicator, it turn red. It tells you that this is an acid, right? And it doesn't only tell you it's an acid, red. Red means pH of 1 to 2. This is your strong acid. So okay, I know there's an acid here. Then you see, when A react with B, you form potassium sulfate. When A react with C, you get magnesium sulfate. Hey, got pattern here already, right? Sulfate. And where did the sulfate come from? Sulfate come from the acid. So what acid got sulfate? Sulfuric acid. And how can sulfuric acid form this? So you look carefully, there is a salt and there's water. Acid plus what? Give you salt and water. Yes, you are right. Base. So in this case, I can write down potassium oxide. I can also write potassium hydroxide. Both is fine. What about C? C. What's happening here? C. Acid plus something give you salt plus gas. Okay. So if you see, look carefully. Salt plus gas. Acid. So we have acid. Then we have gas. Isn't the gas this and this? So that means my answer is either a carbonate or a metal. That means for C, it can be magnesium itself. It can also be magnesium carbonate. And the gas will also change lah. So if it's magnesium, you will get hydrogen gas. If it's carbonate, you get carbon dioxide gas. So be very careful. Look at the word here called name. If you decide to give me a formula, then you will not get the marks because you're not reading the question. So first you read, then you know what you need to tell me, you see. Next, how do you confirm the identity of gas D? Again, it matters, it differs, isn't it? For CO2, it will produce a white PPT, a white precipitate or white solid, white precipitate when passed through lime water. I think you did this in lower sec if I'm not wrong. So let me highlight to help. So if you choose magnesium, you will be getting hydrogen. Then you should be getting this. But if you choose magnesium carbonate, you get CO2, which is this. So it's an either or thing, you see. H2, H2 will extinguish a lighted spleen. Not just that, you extinguish a lighted spleen with a pop sound. Again, I think we have done this in lower sec. This pop sound thing very obvious one, very loud one. In fact, students tend to just the whole lab we just keep repeating the pop sound because it's fun. Yeah. Okay, next one, write an ionic equation use state symbol. Okay. So what you can do is you can write down the normal equation first lah. If not, how are you going to figure out what's happening, right? So normally HCl plus Na2CO3. I know they are AQ lah. Why? Dilute. Dilute means AQ what? Aqueous obviously A means AQ. Give me salt, NaCl sodium chloride is soluble lah. If you don't know, means you need to eat more salt, I guess. CO2 gas and H2O liquid. And if you recall, ionic equation tells me that all the aqueous ionic compound can split into ion. That means I will have H plus AQ, Cl minus AQ from here, Na plus AQ, CO3 2 minus AQ from here. You notice for this particular example, I didn't actually bother to balance my equation at all. Reason being, because ionic equation at the end of everything you balance one. So this is from here, then your CO2G, H2O. Then after that, you can see for yourself what here is repeated. Can see, right? The repeated things, you cancel them out. We call this spectator ion, or simply as the word suggests, the ion don't do anything one. The ion just see only lor. Slackers lah. Hey, Na plus, same, cancel out. Cl minus, cancel out. So my final answer is just H plus CO3 2 minus. Give me CO2 and H2O. But this is not the final answer. Remember to balance. Oh, need to balance. Oh, like that lor. Balance. Yay. Yep. That's it. So you write the overall equation. Then you break the aqueous. Simplify it. Final answer. Okay, next one. Okay. So this is processing the titration results. Sure. So the volume needed here is 32.15. It's just a difference, isn't it? 22.40. This is 32.60. Did I calculate it wrongly? Oh yeah, I did calculate it wrongly. Oops. 32.40. So if you recall, best results means plus minus 0.20. So these two I take. Wait, 152535. Yeah, correct. Yay. Then next one. Oh, calculate. Oh, sure. Let's calculate. So the good thing here is the hashtag hack. First step, equation is given. Yay. Second step, let's change to mole then. Let's change to mole. If you recall, you are supposed to find the average first, right? So the average volume of HCl is 32.4 plus 32.5. 8.6, sorry. So this is basically the average of best results. If it's not best result, it means it's useless result. Why would you include a useless result in your calculation? Right? That makes sense, right? Okay, I have the volume, which means I can find the mole now. Mole of HCl, 32.50 over 100,000 times 0.500. So I should get the answer of 0.01625 mole. Okay, this is mental sum. Let me press calculator. Yep. Okay. Yeah, that's it. I'm done with the second step already. Mole. And third step may be ratio. So I have HCl. I'm trying to find this. Sure. So I see for myself the mole of HCl is to the mole of calcium hydroxide. Oh, 2 is to 1. But I don't have 2 mole. I have 0.1625. 0.008125 mole. Okay, is that the final answer? Read again, read carefully. They want you to find the concentration. So the concentration of CaOH2 0.008125 divided by 25 cm cubed, which is given in the question at the start. Divide by 0.025, you get 0.325 mole per dm cube. 3SF, yay! That's it. So you see your hashtag hack works, huh? Okay, next. Oh, yeah, remember this thing? The soil, the sample, the fertilizer thing that I pass around? It's because when soil is too acidic, some plants don't grow well. Do not grow well. So calcium hydroxide will react with the excess acidity to increase the pH of soil so plants can grow better lah. Yay! Oh, chemical equation with no state symbol. Sure, then let's try lah. So calcium hydroxide plus ammonium chloride. So this is the alkaline ammonium salt, right? Alkaline ammonium salt will give you ammonia plus water plus salt. How to figure out my salt? You see for yourself lah. You compare your left and compare your right. It's like those spot the difference game, you know. Oh, I spot the difference. I spot that my calcium is missing. What else is missing? My chloride is missing. Cross method. Ca1Cl2, which is CaCl2. CaCl2. Only when you are done writing down all the reactant and product, then you bother to balance. Yeah, we're done. Just this all. Yay! So we are done with, I think that's 2022 paper. I think. So now let's move on to the 2021 paper. I think. Okay, calculation. Sure. Haha. Oh no, this one got two gas and liquid and aqueous and okay, fine. You can't use shortcut. Okay, so next thing, equation. Yay, equation. We got equation. Next one, change to mole. Okay, let's change to mole then. Mole of N2, 500 dm cubed divided by 24. 500 divided by 24, 20.83 mole for SF. Cool. Mole of O2, 1200 divided by 24. I get 50 mole. Oh, cool. So this is in line. This is second step. But I got the mole of both my reactant. This means that it is fishy. It means that it is I can't draw this. Sus. Which is excess. So that's up to you to prove. So again, you can use either one of these mole and try. I'm gonna try the O2 lah, for example. So I see for myself, O2 is to N2. 5 is to 2. Okay. So it means 50 mole of O2 need 5 is to 2. 20 mole of N2 for what? For complete reaction. Okay, so 550 mole of O2 need 20 mole. Okay, that's cool. But what is your actual mole? Actual mole of N2 is 20.83. This is still more than needed. Yeah, so therefore, to answer the question, Question is asking for limiting reactant, right? So therefore, O2 is limiting because N2 is more than needed. Yay! Okay, next. We're supposed to find nitric acid. Sure. So now we care about what? We got O2 has the limiting. We need to find nitric acid. Okay, so from the equation I see the ratio is 5 is to 4. I don't have 5 more. I got 50 more. So this is 40 more. Oh, then lastly change lah. So mass of HNO3 40 times 1 plus 14 plus 3 bracket 16. 16 times 3 plus 14 plus 1 times 40. 2520 gram 3SF. Cool. Yay. Okay, next one. You're supposed to write equation. So let's see that. Okay, let's write the equation. What's happening here? I have acid, I have HCl. They say one. Barium hydroxide. Barium is group 2, right? Group 2 means 2 valence electrons, so I'm gonna lose the 2. So I end up with Ba2 plus. Chloride is 17, so you gain 1, Cl minus. Cross method, Ba1Cl2, BaCl2. Okay, so you get BaCl2, barium hydroxide, plus water lah. If you recall, this is acid base, right? This is acid base, salt, water. Balance it. Yay! Okay, you're supposed to calculate, sure. So we need our #hack. So equation is from me, from you, I mean. Yay! Next, change to mole, sure. So the average volume of HCl used is the 21.5. Second step, change to mole. Then let's change to mole. Mole of HCl is 21.55 times the 2.50. 0.02155 times 2.5. I get the answer of 0.05388 mole. Oh, yay, we are done with second step. Third step, mole ratio then. So I have HCl. I'm trying to find this. So mole of HCl is to mole of barium hydroxide. You will get the ratio of 2:1. But I don't have 2 mole. I have 0.5388. So which means you will divide by 2 lah. 0.5388 divided by 2, you end up with 0.02694 mole. So this gives you my third step mole ratio. Then you are supposed to find what? Concentration. Sure. So concentration, if you recall, is mole divided by volume. 2694 divided by 25.0 over 1000. Divided by 0.025, you will get an answer of 1.078, which is 1.08 mole per dm cube. Yay! Next, what happens? Oh, look carefully. Ayo. U means you need to do what? U means step 0. So U stands for refers to product. Remember YP, So product means the given mass of the product. You don't touch it. Do not convert, do not touch, do not convert. So what exactly is this number in this case that I cannot touch? This is my crystals, so don't touch it. Sure. Then that's fine, let's continue. So what do I have now? I have 2 HCl. I can find my barium chloride. So mole of HCl is to mole of BaCl2. 0.05388, 0.02694. So I have the mole of this thing, then I can find the mass. So the mass of BaCl2, 0.02694 times, barium, if I'm not wrong, is 137. Let me check. Barium is, yes, I'm right, 137. Oops, 137 plus 2 bracket 35, 35.5. You will get 137 plus 71, 102,694. I get 5.60 gram. 5.604 gram for SF. Remember, percentage yield, percentage purity is always the smaller mass divided the bigger mass. So 4 divided by 5.604 times 100. What do you write this? So the final answer is 71.4%, 3SF. Yay! Okay, next one, empirical formula, which remember you did your table. You need your table, so let's take a look at the table. Okay, so you see whether it's normal calculation, whether it's your empirical molecular formula, my table works. Amazing. Okay, so I don't need an equation because this is not a reaction. Next thing, I will change to mole. So we are given mass in this case. So I have Na, I have C, I have O. So Na is 3.43, C is 1.79, this is 4.78. Cool. So next step, change to mole. So this is your changing to mole. So 3.43 divided by 23. 1.79 divided by 12. 4.78 divided by 16. 3.43 divided by 23, you end up with 0.1491. 1.79 divided by 12, I end up with 0.1492. 4.78 divided by 16, I will get 0.2988. Yes, that's about it. Then after which, last step is what? Mole ratio, right? So again, let's find the mole ratio. Divide by the smallest ratio. So you get 1, 1, 2. Therefore, empirical formula is NaCO2, which is like, what? Okay, so next one, remember your MR of empirical formula times the multiple equal to the MR of the molecular formula. It's like a multiplier lah. So in this case, 23 plus C12 plus 2 bracket 16 times N equal to 134. So 23 plus 12 plus 32, 67 times n equal 134. So mathematically n is 2. So therefore molecular formula is 2 times. So it's Na2C2O4. Cool. Yep. Okay, next one, the type of oxide. So let's think about it. What kind of oxide is it? Alright, think about it. Yes, you are right. It is an amphoteric oxide. Yay! So this is the lazy. No why, don't ask why, that one, remember? So what's happening here? So it says describe the observation. Now, observations means what you see. What can we see? We can see color change. We can see gas evolved. And we can see solid form. So these are the things that we can see. So when you add aluminium to acid, so what happens with metal plus acid? Acid plus metal give you salt plus H2. So we can see the gas. So you write down that law. So you'll see effervescence of H2 gas. Or you can just say, or you can say, oh, a colorless, there's no color, odorless gas is produced. You do see that, you see bubbles, then you smell, no smell, no color, so it's colorless, odorless gas evolve. Yep. Next, what happened when it's this? Oh, this is a base. Acid plus base. Oops. Acid plus base give me salt plus water. Okay. So you're actually not gonna see anything happening here, isn't it? Actually have lah. You start off with the this is a powder, this is solid. So you can say that, oh, it's a white solid. Dissolve Dissolve to form what color? To form colorless solution. So salt is soluble because this is your AlCl3 solution. Okay, don't worry about. You see, you don't know whether it's soluble or not, right? You don't need to know. All you need to do is read. Iron chloride is soluble. Yay! Okay, next. Copper add to acid. Why nothing happened? Remember? The acid metal reaction has something to do with some reactivity thing. It's a very long list. But I remember I told you that basically your coins do not react. Your silver, gold, copper. So you tell them copper is I cannot say it's unreactive. I can only say it's a relatively unreactive metal. Relatively, So it does not react with HCl. Okay, next, dilute nitric acid is a strong acid. What is a strong acid? Just now we mentioned this before, and it's a very common thing they like to ask, right? Okay, so a strong acid dissociate or ionize fully in water. Okay, 2 marks, to produce a high concentration of H plus ion. Cool. Okay, next. Ionic equation, huh? Sure, let's try and see what's happening here. So, okay, they want you to write ionic equation. Okay, I'm gonna write it here, no space. So I have HNO3, AQ. I know it's AQ because of the word dilute. Dilute means dissolve in water one. Sodium bicarbonate. Okay, potassium, sorry, potassium. So I have potassium. Bicarbonate is HCO3 minus. So this is K, HCO3 is AQ. How I know? They say one equals. So acid plus carbonate give me what? Acid plus carbonate give me carbon dioxide plus water plus a salt. So see for yourself what haven't appeared yet. K plus and your NO3 minus. KNO3AQ. Yep. So ionic equation, you must first still start off with a chemical equation, then you break them apart and simplify. Break them apart, you will get H plus, HCO3 minus, CO2G, H2O liquid, K plus NO3 minus. Then you realize there are some ions that looks exactly the same. And you are right. K plus, K plus. So the final answer is H plus, or 2H plus apparently, plus carbonate, CO2, H2O. Then check that it's balanced. And it's balanced. Yay, that's the final answer. Oh, so the gas in this case is CO2. How do you test for CO2? Very simple, right? You will pass the gas, not pass the gas, you will bubble the gas into lime water. And what do we expect to see? Colorless, white PPT is formed. White precipitate is formed. In the lab or in primary school, you even have the word cloudy. Oh, become cloudy lor, because the solid is formed. Next, dilute sulfuric acid and dilute nitric acid. What is the difference here? Okay. So if you recall, both of these are strong acid. So H2SO4 and HNO3, they're all strong acids. So you tell them lah. So both H2SO4 and HNO3 are strong acids. So if they are all strong acids, does it mean they really have no difference? They have one. Because remember your H2SO4 is dibasic acid. This is monobasic acid. Tell them that lah. So H2SO4 is a dibasic acid. While HNO3 is a monobasic acid. This means that the the concentration of H plus in H2SO4 is higher than in HNO3. I mean, you have 2 H plus versus 1 H plus. Of course, 2 is higher, more lah. That means your H2SO4 would react the effervescence or the gas evolve is more vigorous in H2SO4 when it reacts. Yay! Okay, very complicated question here, but don't panic. Let's take a look. So I have a table with the 3 indicator here. Alright, that's fine. Then what else? We have some color being given. Then some pH range and this weird looking graph thingy. Okay, right, sure. Yeah, and let's take a look. So we are supposed to explain, describe. So it means you need to tell me with more details. Not only tell me, after you need to explain in terms of the ions, why the 6.1, the shape is like that. Sure, so let's try and explain that then. So it's a 2 marks, so let's take a look. So, oh wow, at the start, your pH we can see here is about what, 13 to 9, 8. So if you recall, 13 and 8 means what? So the pH of NH3 is, it ranges from 13 to 8 to 13. This means that this is because why? Ammonia is a weak alkali. So it dissociates partially in water to form low concentration of OH minus. Yeah, and remember pH 8 to 13 is considered 8 to about 13, 12 is your weak alkali range one. Yeah, no? So you have OH minus, lesser OH minus, that's why the pH is 8 to 13. But this is the shape, so that everything here, right? So there are three parts, I guess. Then you realize that there is a segment that is, wait, what shape? Then take a look again. After that, what would you say? I would say that the pH of sulfuric acid is 1 to 2. Why? Because it's a strong acid. So dissociate fully, high concentration of H+. That's why the pH of 1 is to 2 at the end. Yep. So use the table and figure out what is the indicator for the titration. Okay, so 6.1 and this. So wow, what is this graph? I got step 1. So let's try and read what's this step. So here is here. The endpoint pH is basically the step the start to the end of the step. Okay, so this is something new that they're saying. That is fine. So for this, you can see that the step is about pH 8 to pH 8 to pH what, 3? So which means, which one is the better answer? Cannot, yeah, about 8, pH 3 to pH 8. Okay, you see, let me highlight, play with colors. 6 to 7.6 is saying that is 6. Oh, the color is quite bad. 6 to 7.6. Such a small pH range. What if it's 9.3 to 10.5? 9.3 to 10.5. It's out of the step already, you see. Lastly, 3.5 to 5. 3.5 to 5. So the possibility here I have would be either my bromometal blue or metal orange. Both also quite feasible. Color wise, yellow to blue, colorless to blue. They're both quite okay, I suppose. So in this case, what is the indicator you will use? So you can use either one. They are more or less quite inside. 3.5 to 5. And what do you need to say? You just say the pH in the step in the pH change, it coincide with your end range pH. Coincide, it just nice tally. Yep, that's about it. Then now we're left with the last year, which is I believe 2020. I'm not very sure if I printed this out for you. If no, then you can still look at the questions, I guess, and try them online. If you have, then you can look through and discern and mark. Okay, extinguish a lighter spin. So the extinguish a lighter spin is your hydrogen, right? Your oxygen is relight a glowing spleen. Yep, ammonia is ammonia turns moist red litmus paper blue. So these are some of them. Okay, which metal we have acid to form gas? Think about it. Acid plus metal give H2 ma. So this gas is H2. Then not all metals, right? If you recall, there's some reactivity content to it. So the bottom three metals, which is your coins, they don't get to react, unfortunately. Which means answer is copper. Your coins are copper, silver, gold. Okay, which one turn? Oh, litmus paper blue. Blue means it's alkaline in nature. So which of these things is alkaline in nature? Ammonia, no? Ammonia gas is a weak alkaline, ma? React with alkali. So we learn acid. Acid, we have alkali, ma? So is there any acids here? No acid. Okay, fine. But I have the next best thing. Acidic oxide. Sulfur dioxide, yeah. Dang. Yeah, then what else? Acidic oxide, we have the hydroxide. Aluminium oxide also can, huh? Because this is an amphoteric. What's an amphoteric oxide? Amphoteric oxide react with both alkali and acid. So it is also possible. What else here can react with alkali? These two common ones react with alkali. Yes, can be sulfur dioxide. Yeah, actually that's about it. Okay, next one. Lemon. Okay, let's take a look. We have 1, 2, 3, 4, 5, 6 question. Okay, 5 question. Oh no. Okay, let's try. Okay, so this tartaric acid is weak acid. Sure. Then tell me what's the name. See again. How many times already? Yeah, I have to ask definition, huh? So weak acid dissociate or ionize, depends on which word you prefer. Partially in water to produce low concentration of H+. Cool. Next, why is there a fizzing sensation? What is happening here? So read their context, no? Fizzing is in the mouth, huh? Okay, cool. And they say what? The sherbet thingy contains hydrogen carbonate and tartaric acid. Eh? Isn't that a bit weird? Got carbonate, got acid. How come inside the sweet nothing happens? Weird. So tell them lah. So the water in the mouth got water, right? The water in mouth allow my tartaric acid to dissociate. Oops. Partially in water to form H plus ion, which are responsible for what? For the acidic properties. Yeah, that's why you see, if there's no H plus, there's no acidic. So once you touch your mouth got water, the thing can dissolve, they can be acid, they can react. Produce of carbon dioxide. Oh, apparently what you have to do, you need to describe how to confirm that the gas is CO2. So it's a gas test lah. And not just describe, you also need to tell me what you expect to see. Sure. Bubble the gas into lime water lor. If white PPT or white precipitate is seen, that means it is right, because the carbonate react with acid. Oh, cool. Okay, next one, calculation. Sure, bring it on. Where's my paste? Hold on, let me go and get the hashtag hack for mole. Hashtag hack for mole is here. Okay. Where is it? Oh, it's here. Okay, let's write equation. Okay, say symbol. Don't panic, Say symbol. They don't remember the solubility table yet. They will tell you. Just need to read, Read. Okay, copper 2 oxide. So I have copper 2 plus and O2 minus. So I have CuO, and this is a powder. Powder means solid lah. React with heat with hydrogen, and we know that hydrogen is a gas. Produce copper molten plus H2O vapor. Okay. Then let's see whether it's balanced. Oh, it's balanced. Yay. So first step, equation. We have the equation. Second step, let's change to mole. Mole of CO is 2.5 over 64 plus 16. .3125 mole. Cool. So you're done with second step, mole. Here is the mole ratio. So what I have here is CuO. I'm supposed to find hydrogen. So mole of CuO is to mole of H2, 1 is to 1, 0.3125, 0.3125. Cool. Then volume of H2, 0.3125 times 24. 7.50 dm cube, 3SF. Cool. Find the mass of copper. Okay, so it's essentially this lah. It's telling me that I got CuO. Can you find the copper? Sure. So mole of CuO is to mole of Cu, 1 is to 1, 0.3125 is to 0.3125. So mass of Cu is 0.3125 times 64. 0.3125 times 64. 20 Tg. 20.0 G3SF. Oh, oops, where did it go? Yep. Okay, next. Purity. So the usual hashtag hack work. Okay. So purity. So hashtag hack. Hashtag hack is here. Equation we have. Yay. So oh no, purity means step 0. Purity means reactant. You know YP? YP is what? U product. So reactant means the given mass of reactant do not touch. So what is this number that I cannot touch? Which is here. Leave that alone. So step 2, mole of CO2, 1200 divided by 1000 divided by 24 equal to 0.05 mole. Oh yeah, we are done with second step, mole. Then your mole ratio. You have CO2, you need to find something to do with this. So mole of CO2 is the mole of 1 is to 1, so 0.05 is to 0.05. Yay! Next, mass of CaCO3 is 0.05 times 40 plus 12 plus 3, 16 equal to 5 gram. Okay, you have 5 gram. 5 gram, let me calculate. 0.05 5 gram. Cool. Then what next? You are supposed to find the percentage purity. No, this question got to be about trap. Because you need to read. Arenite is supposed to be silicon dioxide. Calcium carbonate is an impurity. So that means mass of, the percentage purity is the smaller mass divided by the bigger mass. (17.5% 3SF). So they say already is mainly silicon dioxide. The calcium carbonate is like impurity. So its impurity shouldn't be high percent. Yay! One, two, two more questions. Yes, we can do this, people. You see again, this is your empirical formula question again. So we shall write the table, change the mole ratio, then compare. Yay! So let's take a look. So there's no need for equation. Nothing is reacting here. Yeah. Next we have mole. Table. So we are given what? Percentage by mass. Sure. So I have C, H, N. C, H, N. So this is 74.0, I think. 8.7 and 17.3. Sure, so that's the second step. Second is change the mole. Mm, 74 divided by 12. Oops, 74 divided by 8. 74 divided by 12. 6.167. 17.3 divided by 14. 1.234. Lastly, ratio. So you compare, divide by the smallest ratio. 6.167 divided by 1.236. 6.167 divided by 1.236. 4.989. 8.7 divided by 1.236. 8.7 divided by 1.236. 7.04. 7.039 actually, sorry. So therefore, empirical formula is C5H8. Oh, oops, not ON. Yep, so C5 is 5 times 1862.2. So 5 times 12 plus 8 plus 14. 162.2 divided by N equal 2. Therefore, molecular formula is C10, H16, and 2. Cool. Last question. So, okay, let's read. They say acidic waste is accidentally poured into the water. Then this chemist is told to check the NaOH. Yep. So what's happening? Why must the pH of the mixture be measured? Okay, it says you want to determine, you use a NaOH to neutralize, right? You see, the final pH, what does it tell you? Final pH tells you, because why? You are adding in, so you're adding alkali to the wastewater, acidic wastewater. So why is that the pH must be measured? When do you measure it again? You also measure it at the alkali to the 100 cm cube to neutralize water. So why the pH must be measured? So it can allow us to know exactly when the reaction ends. All colorless ma. In which of the experiment has the acid not need to try before? Sorry, which of it has the acid not been neutralized yet? Okay. And how do you know that? Very simple. Answer is 1. Because the pH, the final pH, is lower than 7. So, 1 because the final pH is lower than 7, which indicates that the final pH is lower than 7, which indicates that acid is present. Exact volume of alkali to the acidic wastewater rather than adding a large excess. How? What's happening? It's very wasteful if you just add a large excess. Well, so now you have exact. What does it mean? Why is it important to add exact volume rather than large excess? I mean, obviously, you don't want to waste, right? Do not waste chemicals. And your chemicals go into the drain, you also need more treatment and everything. Essentially, don't waste chemical. Isn't that not wrong? Yep. What else do we need to do? Do not waste chemical. Alternative substance that can be added through the seawater. So what is this thing we can add to remove the acidity? So you know, right? You can use your calcium carbonate, for example. Is this? Yeah. This one don't need to do, right? Because we already run salts. And we are done.